Hello students, this is Nitin Patil, Assistant Professor from Computer Science Department, Savitribai Phule University. Considering earlier introduction to my first elective, now I am going to introduce one another elective called Low Level Assembly Programming. This course is intended to write assembly programs. Along with it, we are going to see few internal details of operating system by making use of sandwiched approach of C and assembly together. As well as, apart from it, we are going to see few more details about different utilities available for system programs. Considering the reference books for this course, I am going to make use of these two books specifically, Professional Assembly Language by Richard Blum and Guide to Assembly Language Programming in Linux by Sivaramadan Namudi. Apart from this, we definitely will be making use of Intel manuals as and when required. So the main objective of this course is like this. Upon successful completion of this course, you will be able to understand what happens at execution level, as well as you will understand how these low level operations gets executed. Because the way programming languages put everything in front of us, everything is so sophisticatedly organized, and we may not go into greater detail, or we may not understand what exactly is happening towards that side of the system. Another goal, another objective that I'm assuming would be like this particular course will give you understanding of thorough understanding of 32-bit instructions. Apart from this, you definitely would be understanding greater details string instructions, which is a kind of good utility or good instruction set available with Intel. As well as we are going to see floating point operations, how these floating point operations are carried out. Like on processor, generally we have seen that there is a co-processor added, or even processor is built with now floating point support or operation support. So we will try to see if at all it is to be programmed, what kind of instructions are to be used. So as well as we are going to see use of macros, how macros are pre-processed, what happens at that particular level of pre-processing. So to register for this course, I am assuming some prerequisites. Those prerequisites are like general basic usage of Linux operating system. You should know basic Linux commands. Along with it, you should have good hands-on knowledge of C language along with GNU compiler, GNU C compiler collection. Moving further, moving forward with respect to the course contents, so I have divided my whole course into 5 different units. So first unit definitely would be addressing tools of the trade, which like if I try to talk about a distribution of topics, this would be a bit smaller in comparison to rest 4 topics. So this should finish in maybe 1 or 2 weeks. So this particular unit called tools of the trade would definitely give you some idea about different tools available on Linux operating system. Then we are trying to see Intel 32-bit instruction set. We'll try to understand instruction format. We in previous semester in System 2 course, we have seen bit introductory information about how these instruction formats are defined. Even we have seen few aspects related to translating these instructions to object level form. So we are going to go in greater details now about most of the instructions, though we introduced few instructions only in the previous semester. This will give you complete idea, like almost like we are going to see 70 to 80% of basic instructions included in this particular unit. So we'll definitely writing some code relate by making use of those instructions. Nextly, we'll try to understand different string processing support or string operations supported by Intel. Now to accomplish this, we'll be definitely making use of system calls. These system calls are supported by every operating system. Now from operating system to operating system, the reference may vary. Like for example, in Windows, we call it as interrupts. In Linux or Unix operating system, we do call them as system calls. So we'll be talking about system calls access, like how exactly the system calls are to be accessed and how exactly they can be sandwiched together with C also. In fourth topic, it would be floating point operations. Okay, and last one would be addressing something called as macro preprocessing. Now let us try to understand what exactly these units are going to address. So first unit, as I mentioned, we are going to start with understanding different bin utils. So as in a sample case, I have taken a few examples over here, which we are going to address in greater detail. So we'll start with probably profiler, then archive creation, archive library creation. Then we will try to see how exactly the data collection or symbol collection is done using NM, OBJDUMP, and readelf. We are going to see few other utilities available on Linux operating system called size, strings, and string. So outcome of this particular unit is expected, expected would be like you should be able to understand what happens at compiler level as well as translation level. So to accomplish these all utilities, we will be taking help of GNU-C compiler collection. So we'll try first understand how exactly the translation is done by the compiler and what are the different stages included and how these utilities would be helping us over there. So apart from this, we definitely would be addressing something related to a debugger. We'll be understanding in greater detail how to debug a program through GNU debugger GDB. In second unit, which addresses completely an IA32 instruction set, basic instruction set, where we are going to consider different instructions apart from like what are the basic instructions that we have seen in previous semester. So we'll start with by understanding how the assembly programs are organized. What is the structure of an assembly program? How the program is divided into different subsections and so on. Then we'll start with some few data transfer instructions. We will see some direct use as well included in the while writing assembly programs. We'll then move towards arithmetic instructions. Then we'll address conditional and unconditional jumps along with loop. And definitely important thing would be few logical instructions. So outcome, like expected outcome of this unit would be, you will understand few internals from OS perspective, what happens at that level. Even it would not be only using instructions. We'll try to understand how the flag register or how the internal registers of the processor are used while executing these instructions. So we'll understand basically what I said over here is like we'll try to understand these instructions in greater detail. And as to accomplish this unit, we'll write few simple as well as few complex assembly programs. Third unit, as I mentioned earlier, would be addressing something called as string processing and system calls. Now this again is one important point from operating system point of view. So like when assembly programming or assemblers are introduced, at that time definitely there was a distinction between like how exactly the procedures are to be called, how to differentiate between procedures and subroutines. So we'll try to understand making use of some call and rate kind of instructions. We'll try to see how internal functions inside assembly program, how external functions written outside the file, outside the source file are called. So we'll try to write our own functions. Some functions would be written in C, some functions would be written in assembly, and it would be mixed approach that we are going to make use of to understand this call and written instructions. Later, we'll address one important aspect from assembly point of view called string instructions. This definitely will give you a brief idea about how the string operations are accomplished. To understand these instructions, we definitely require some instruction prefixes. So our next target would be like understanding these instruction prefixes, how these instruction prefixes are used. And towards last part of this particular unit, we are going to address something called as system calls, which is one important aspect of every operating system. So considering the outcome of this particular unit and inclusive of these 5 subunits, I expect you to understand how the function calls are to be given. Now, though you have given function calls in your high level languages, but at low level language, what happens? What adjustments are to be made by us to accomplish a function call? Then we will try to understand importance of few flags and one important aspect, like one important flag, which is considered for string processing called direction flag. We'll try to understand how this direction flag is to be used. At the latter stage, we'll try to, like as I said, expected outcome part, we are going to see how these prefixes are to be used and the system calls usage through C as well as through assembly language. Fourth unit, as I mentioned earlier, is like floating point operations. This is one important instruction set rather I should say, because like what are the standard instructions which we are going to address in first second unit of this particular course, they do not address any real operation like floating point operations. They are not useful whenever I am trying to take a division, and if division is considering some decimal point over there, then ultimately we cannot accomplish that part. So how these floating point operations are to be carried out, so that would be our main target over here. Then we'll try to work with some series and sequence operations. We'll try to write few arithmetic problems where floating point operations are involved. Even we will address some advanced mathematical functions which are generally used in mathematics, and even high level languages do support those function calls by taking help of this assembly language program, assembly language instructions only, like which we categorized into floating point. So expected outcome would be you will understand how this floating point unit stack is used. This plays an important role over here, like to carry out these floating point operations. Apart from this, when a floating point instruction get executed, how FPU is used internally. So we will understand basically usage of FPU and floating point instructions altogether. And last part for this unit, like as a expected outcome would be like I expect you peoples to create library of functions which would be used by you in either C or maybe in assembly language program written by you only. And as a last part, this is one important aspect for every programming language: pre-processing, macro pre-processing. Now to accomplish this pre-processing, we definitely require some help from the translator. So like every programming language, like if it supports macros, then there definitely a stage included called pre-processing. Now earlier unit which we have seen in fourth unit, where we talked about functions, we'll try to differentiate how functions are different than macros, or how macros are different than functions. We'll try to compare usage of them at that particular level, pre-processor level even. Now there is a separate syntax included rather, and from case to case rather, this syntax may vary how to write the macros. So we'll try to understand how the macros are to be written and importance of macro pre-processing definitely. Now, as an outcome point of view, expected outcome is like understanding definitions, how exactly the macro definitions are to be given, and how exactly this expansion process is carried out by the preprocessor. Then we'll try to create macros for string operations. In few cases we will make use of string instructions specifically, and few cases we will write some string operations, or we will implement string operations without using string instructions. So we will create our own library sets for those aspects, and then we will try to make use of system calls in macros as well. So to accomplish all this stuff, we'll be making use of NASM as an assembler. Okay, and linker would be GCC. Like LD is an internal linker which will be handled internally. We'll definitely understand those details at the later stage. How in our first few weeks rather, you will understand that process. Considering the evaluation part, like generally through CBCS system we have internal and external part. So internal evaluation mechanism is defined this way. So there will be programming assignments. Definitely these programming assignments would be contributing towards the internal assessment, and contribution of them would be 15 marks. We'll take 3 online programming tests. So these would be 25 marks each, and each test, like if we see, would be taken for 25 marks, and we'll take average of those 25 3 tests of 25 marks each. Then we will have weekly programming in class performance. Like this would be kind of activities rather. Those activities would be based on your weekly submissions apart from the assignments. Whenever I am teaching you some particular program, writing some particular program, I may not write the complete program directly. I will explain that program, and you are expected to finish that program by the end of maybe that class. So every class would be like my session would be probably say of say 20 minutes, and outcome point of view I expect you to finish writing the programs maybe sometimes 30 minutes or sometimes 1 hour. So that the weekly programming in class performance definitely would be contributing toward 10 marks. Now let me tell you, though I have given this as a rough estimate of how the distribution would be, we may make changes depending upon if some more efforts are to be put by you. Now external point of view, external examination point of view, we will have programming problems with multiple choices. Like you would be having multiple choices to choose from, and then accordingly you are going to write the programs. So this is how the whole course would be organized. In case you have any difficulties, you can contact me on my email, which was mentioned by me earlier. Okay, as well as I am available on WhatsApp. Thank you very much.